Preview.
Hello everyone and welcome again to the new basic learning. In this session we are here with the chemistry session and the chapter is the language of chemistry. If I talk about what is the language of chemistry, if I ask you what is the language of chemistry, the language of chemistry, first we will talk about the symbols, then valency, then radicals, and finally the chemical formulas. One thing I want to clear to you all, that if you are doing the chemistry, so you must learn or you have to learn all the chemical formulas given in your particular book. So it becomes easy to solve any equation or to understand chemistry. Actually, this is not a very tough subject. If you will take interest in this, then only the chemistry is easy. So if I talk about the symbol first, other things we will talk about that later. First is the part that is symbol. What is symbol? A symbol is the shortest form, or you can say the representation of any element or anything. So here I have taken, in 1807 John Dalton suggested figurative symbols for atoms of elements. Example, oxygen. The symbol for oxygen in 1807 was this. Who suggested? John Dalton. For sulfur, it was this. Nitrogen, this. Hydrogen, this. But later, it becomes very difficult to, you can say that, to figure all the symbols because the number of elements increases. Okay, so it becomes difficult. So in 1814, Berzelius suggested a simple system of representing elements with the symbols. Simple system of representing atoms with symbols. He put forward certain points for presentation. Now, the points which I am going to tell you are, in most cases, the first letter of the name of an element was taken as the symbol for that element and written in capital. That means the first letter of the name, of an element, was taken as a symbol. This is the symbol of carbon, C, for that element and written in capital. Okay, you cannot write this in C, small letter. You have to write this in capital letter. Sulfur also, the S is written in capital letter, and this is the name of that element. Next, in other cases where the first letter is already adopted, it means the first letter is already adopted. It means that here C also, carbon also and calcium also, both starts from C letter. So first letter is already adopted. That means in carbon the C symbol is already there. So we cannot write that for carbon it is C1 and for calcium it is C2. Okay, so the initial letter in capital together with its small letter from the name were used. It means Ca together with its small letter, that is A. So the symbol for calcium is Ca. And the silicon, if I talk about silicon, the symbol for silicon is Si. Okay. And in other cases that the symbols for some metals were derived from Latin names. Latin names, the symbols for other metals were taken as Latin names, from the Latin names. That is, the Latin name for copper is cuprum. So the symbol is Cu. And the iron name, Latin name for iron is ferrum. So the symbol is Fe. Sodium, natrium, the symbol is Na. Gold, Latin name is aurum. So the symbol is Au. I hope this part is clear to you. Now we will talk about the valency. So if I talk about the valency, okay, second part. First we have completed that is symbol. Now second is the valency. What is the valency? Valency is the combining capacity of an atom of an element or radical with the atoms of other elements or radicals to form compound. Let me write this. Valency is the combining capacity of an atom of an element or radical with the atoms of other elements or radicals to form molecules. Okay, so there are two types of valency, that is positive valency and negative valency. Okay, two types, that is first is positive and second one is negative. If I talk about what is the valency of oxygen, the valency of oxygen is 2. So it will be written as O2 plus, and it will be considered as divalent. Monovalent is for the first, divalent is for the second, trivalent is for the third, and tetravalent is for the fourth. So this is the positive valency. If I talk about what is the valency of hydrogen, so the valency of hydrogen is 1 and it will be written as H1 plus. These are the positive valency. Now if I talk about the negative valency, okay, so the copper has two valencies, that is one also and two also. How? When we call that valency as the variable valency. What is variable valency? When a valency exhibits more than one valency. Okay, suppose the name of the Latin name of the copper was cuprum. So the valency are 2. So it will be cuprous for the first and cupric for the second. Okay, cuprous for the first and cupric for the second. So this is the positive ones, which will be taken as Cu. Okay, the symbol is Cu only. 1 plus. And for cupric it is, the valency for the cupric is 2. So it will be given as 2 plus. Okay, so I hope this is clear to you. Now we will talk about the radicals. Okay, what is a radical? A radical is a atom of an element. A radical is an atom of element or a group of atoms with different elements. A radical is an atom of an element or the group of atoms of different elements. Okay, the group of atoms of different elements that behaves like a single unit. Okay, or shows valency. So here I am with the positive radicals. Positive radicals we called as cations and the negative radicals we called as anions. You know also that radicals is of two types, that is basic radicals and acid radicals. So the basic radicals are positive ones that we called as cations and the Acid radicals are the negative ones, which we called as the anions. So here I have taken the valencies, that is monovalent, divalent, trivalent and tetravalent. Monovalent is for the first, divalent is for 2, trivalent is for 3 and tetravalent is for 4. Suppose the example is given you potassium. Valency of potassium is 1. So, and the symbol of potassium is K. We are putting the positive radical. So, it has positive radical, that is K1 plus. Calcium, symbol of calcium is Ca and the valency is 2. And it has positive charge. So, Ca2 plus. Aluminium, that is Al. Valency is 3. Symbol is Al and we have positive charge, that is Al3 plus. Al3 plus, sorry. Then we have tetravalent, that is 4. It has, we can take the carbon. Valency of carbon is 4. So, and the symbol for carbon is C. We have positive charge, so C4 plus. Now the negative ones, that is negative radicals or the anions. Chloride. Chloride, you can take also chlorine. Okay, but when suppose I am giving you an example, sodium chloride. Sodium chloride. So sodium is the positive, that is Na plus. Chlorine is chloride, but means we are putting the chloride. Okay, so Cl is negative. Here also chloride is for negative charge, that is anions. Cl valency is 1 and charge is negative, so Cl1 minus. Sulfate, the valency for sulfate is 2, that is for sulfur. Okay, but we are putting it sulfate, so SO4. The formula is SO4. Okay, so and valency is 2 for sulfur. Negative charge, so SO4 2 negative. Phosphate, that is phosphorus. Okay, so the valency for phosphorus is 3 and the symbol is PO. Phosphate, if phosphorus is P and we are doing the phosphate, so PO4 3 negative. Then carbide, that is 4. Carbide, it is carbon. Okay, but here we are with carbide and the valency for carbon is 4. Okay, carbon is valency is 4. So C4 negative. I hope this chart, the positive radicals and the negative radicals are clear to you. Now we will move to chemical equations. Before moving to chemical formulas, first we have to talk about the compounds. Okay, compounds. What is compound? Yeah, what is compound? A compound is a pure substance. What? Compound is a pure substance which is composed of 2 or more elements. Okay, which is composed of 2 or more elements and combined chemically in a fixed proportion. Suppose the example I am taking here is H2O. Okay, H2O. So it is composed of 2 elements, that is hydrogen and oxygen. Okay, it is a chemical equation. Okay, and it is of it composed of 2 elements, that is hydrogen and oxygen. So I hope this compound is also clear to you. Now we will move to chemical equation. Now we will do the chemical equations. Okay, so I have taken example here. Hydrochloric acid plus sodium hydroxide gives sodium chloride plus water, and the chemical equation for this is HCl plus, that is hydrochloric acid, HCl plus NaOH. Sodium is Na, hydroxide is OH, gives NaCl, that is sodium chloride. Sodium is Na, chloride is Cl plus water. Water symbol is H2O. So this is a chemical equation. Now What is this? This is an arrow. What it represents, or why this is here? It shows the direction. Okay, and it means the change is not reversible. It means irreversible. Okay, and sometimes in chemical equations you also see this type of arrow. Okay, what does it mean? It means that the change is reversible. The change is reversible. Okay, if I take an example, suppose A plus B gives AB. Okay. So here the change is not reversible. It means it is irreversible, and when A plus B gives AB, so AB cannot break down into A and B. Okay, if suppose A plus B is given you like this arrow, so it means that the change is reversible. It can be reversed. It means that A plus B gives an AB, so AB can break down into A and B when the symbol is this. Okay, and we can add here also when the heat, temperature or catalyst. So we write it here. Suppose A plus B gives AB at 450 degree Celsius. It is the degree on which it is giving. So this was the difference between this arrow and this arrow. Now we will do the equations. There are two methods of balancing a chemical equation. First one is the hit and trial method. And another one is the partial equation method. Okay. First is the hit and trial method and second one is the partial equation method. First we are going to do with the hit and trial method. Okay. So the hit and trial method follows the law of conservation of mass. And what the law of conservation of mass says, suppose here A plus B. One thing also I want to clear that before starting the hit and trial method, this is a compound. A is a compound, B is a compound. This forms, it means this is the left hand side, so it is a reactant. When A reacts with B, it gives AB, that is product. This is the product side. Okay, so reactant side, or you can write as left hand side or right hand side. The A plus B, that means A reacts with B, this is the reactant side, and the product which we get as AB, so this is the product side. Now we will do the hit and trial method. Suppose the example is given to you, C plus O2 gives CO. So the number of moles we will count first. C is here, C is also on the product side, O is also here in the reactant side, and O is also in the product side. Okay, so what the law of conservation of mass says is the first we have to count the number of moles on reactant side also and product side also. Here when there is nothing, so it is considered as 1. Number of mole for 1 is C is 1. Number of mole for O is 2. Okay, O is 2. Now come to the product side. This was the reactant side. Okay, now here this is the product side. So here number of mole for C is 1 and O is also 1. Okay, so what we will do to make it 2? Here the oxygen was 2 but here is 1. So what we will do to add the number of 2? We will add 2 here. Okay, so it will be 2 because when we are, and C also becomes 2 because 2C and 2 for O. So it is not that if the 2 is just nearby the C, so the number of moles for C is only 2, only for C, but at the same time this is for the C, O also and C also. So the number of mole for C also becomes 2 and O also become 2. Here number of mole for oxygen was 2 but here 1. So we will add 2 here also. Okay. Now the equation is balanced. Okay, this is the hit and trial method. One other example I will take. Suppose here it is given Na plus Cl gives NaCl. Na plus Cl gives NaCl. You can take 2. Okay. So here this is the reactant side, this is the product side. Number of mole for Na, that is sodium, is 1. Chlorine also have 1. On the product side, Na is 1. Chlorine is also, chlorine has 2. What we will do here to make it also 2? We will add 2 here. So the number of mole for chlorine becomes 2. This is balanced, this is balanced. The chemical equation is balanced. I hope the hit and trial method is clear to you. In the next part, I will be doing the chemical equations related to this part. It means hit and trial method. Okay, hit and trial method, I have given the 2 examples. Solve the examples and related to this, solve some questions related to hit and trial method. In the next part, I will be doing the related questions, some more questions, and the second method, that was partial equation method also. So this I am ending this part. Till then, stay happy and stay tuned. Thank you for watching.